containers are, where we've come from a bit, and some of where we're going. So if you're looking to find out how to use containers, this is not the talk for you today. So I'm Tyler. I'm a system engineer with Amazy. Yeah, you're welcome. System engineer with Amazy.io. We're a Drupal hosting company. I use TWARD-NW pretty much everywhere online, so if you want to look for me, you can. So it is no longer a test. Containers are here, but don't panic. Grab your towel. We'll teach you what they are, what they mean, all those sorts of things. So first we'll start out defining what containers are. You hear containers and Docker used a lot at the same time. They're not the same thing, but I'll help you differentiate what those are, and then just a small glimpse of some of the things coming down the pipeline. So starting off with what is a container? Who's using some sort of Docker container or anything like that? I'm not talking about how to use them. I'm only talking about what they are. So if you're looking for how, I won't have much for you today. That comes later. Okay. Container, a lot of people treat it like a virtual machine, but they are not. They're definitely not a virtual machine. We'll make some comparisons here. We started with physical servers. A physical server is kind of like a city, infrastructure, things like that. And we can draw some parallels between how a city works and how a physical server works, because that's where we started at. A city provides a power grid that you connect to. You could equate that to a CPU. Moving electrons around. Streets. We'll call that the RAM. We're putting data in there, moving and shuffling it around. A water system, we've got storage. City is providing us all sorts of really base layer elements that we're using on top of it. And then a highway where we're actually connecting to other cities, other servers, and moving things in between each of those. This is kind of, you don't see a lot of use of this as much anymore because we have virtual machines, which are part of the city, using some of that stuff, but isolated from that larger unit as a whole. So in your house, a few more parallels that happen. Your house, it connects to the water system of the city, but it still has its own plumbing. Virtual machine is connected to the operating system loosely of a physical server, but yet it's still a full operating system. Your house will have its own isolated heating. Same thing, a virtual machine will have its own completely isolated network stack, still using some of the elements from that city, but it's implementing a bunch of it on its own. Inside of a house, back to the power grid, it has its own power distribution. We'll call that the kernel. Even though the physical server has a kernel that's running, doing tasks, taking care of things, that VM inside of there is still running a full kernel no matter what you do. And then doors and fences around your house. A VM has to maintain its own firewall. That host system is not there to, the city is not there to provide isolation and protection. It's the house is still responsible for making sure it's secure, that fence is up, and only the right people are having access to it. Then we move into containers. A lot of small dwellings, like an apartment, all in one location. So the parallels here, in our apartment building, we have shared plumbing. You don't have to connect to the city water supply for your apartment. You have that on your own inside of the building. We're no longer having to provide a full operating system to a container like the VM needs. We're able to isolate that, keep that as small as possible. Only the bare minimum is running. In an apartment building, we're sharing our heating and cooling systems. You still have some control but your unit is under its own power there. You can do what you need. Container, it's the same thing. We're sharing the kernel of the larger operating system that it's sitting on top of, but some of the parts are still of our own control. Power distribution, there's a engine, that we'll talk about later, that sits underneath of all that stuff, providing a lot of supporting services there. And then our shared fences that the fences that we had on the house, now the apartment building is maintaining, a major firewall to the outside world, that you no longer need to do the heavy security, but you can have, your own door into your apartment, and have control there, but you don't have to worry about a lot of the attacks that are going to come in. So you get a little bit of isolation provided there. There's advantages to this as we move down through those layers. Historically, with physical servers, if you needed more resources, you had to do a new physical server. When we move down to VMs, though, you can put multiple VMs onto a physical server that they get advantage of using those shared resources. You put some systems together that aren't doing a lot of work at the same times, and you can balance those things. And you take that even a step further with containers, that we're able to put a lot of them when they're not thinking, because they're not having to provide all of that underlying infrastructure like a VM on their own. We can save even more resources. So why do we actually use containers? Lightweight, that minimal OS. You can build an image that's very, very small. A VM, you might bring that image down to your computer to do some work, or into a server, and the VM image might be 20 gigs. Maybe you get it down to 10 gigs for a pretty full-fledged application. In a container, we're super lightweight. We're talking, some of the small ones are 2 megs. Pretty common to see 20. We have a few that we run that are around 200, so you can save a lot of space. You can move them around faster. When you need to start one of these things, because you're not starting all of those extra things, you're not running your own kernel, you're not having to run your own firewall. They're extremely fast. You can start them up in just milliseconds. It doesn't take long to get one of those things going. And even though they're sharing the firewall of the parent system, they're still fully isolated from each other. You can set up movement between them, but they don't, by default, talk to each other, and you can't move from one to the other without the right permissions set up for you. So we get some very good security by isolating these things on their own. Because they're so small, so fast, secure, we start to build what we call microservices, where you have a single container that's running, that's doing one job. In a VM, if you're running web hosting, you might have an Apache server running, MySQL, PHP executing somehow. With containers, we can take and break all of those things apart. You can have one little tiny image of Nginx that's running and just doing that job. It might be talking to another container that's doing PHP FPM. And then somewhere else in that infrastructure, you have your container running your database, Maria, MySQL, whatever you choose there. So you can split all those things up, so you remove reliance on each other in some ways. You can update one thing at a time. You don't have to worry about how closely knit all of those things are. And on top of all this, they can still run the side of the VM. So we don't have to get rid of that advantage of not needing a whole giant physical server to have resources just sitting waiting. We can still put these inside of a virtual machine and then divvy it up as we need. So running without the virtual machine, this is a server that's only doing Docker, something you might run yourself. Looks pretty similar to how we would run apps before. The physical server is sitting there providing the underlying resources. There's an operating system of some sort. That engine, container engine, here we're showing Docker, and then on top of that, the different apps. So each one of those is a container that's running. You might have that Nginx server, app 2 is PHP, on our database, and they're isolated from each other, providing the things that they need to run for themselves, and then they can talk to their neighbors if they need to. If we throw a virtual machine in there, we can do a lot of things. And then this is what it will look like when you go to a cloud provider. Most cloud providers, I shouldn't say all, will provide you with a VM. You can buy physical servers still. It's becoming much, much less common. But instead of just having our operating system on top of the physical server, we have what's called a hypervisor. And so it's managing the virtual machines on there. And then each one of these other boxes now, we can run Docker inside of there, just isolating things a little bit further, getting better usage of all of our resources. So who's using containers now? You hear a lot of people are using them for development work. You see that, but in the real world right now, a lot of the Drupal hosting companies are already using containers. Platform, Pantheon, Amazy.io. We already have a lot of containers systems running in production now. Companies like Visa, they are transitioning their workload over to run on containerized services. 100,000 transactions in a day, and they've been ramping that up as they're testing their systems and moving along. So they can handle a lot of data, a lot of spikes, things like that with the system. Netflix is 100% containerized. 1 million is probably a conservative number, but millions of containers that they're starting and stopping every single week to deliver you the content, to transcode content, all of that stuff to deliver you a TV show you can binge watch. And then Alibaba. Singles Day is akin to Black Friday in the US, and they processed $12 billion worth of sales in that one day, and their entire infrastructure to handle all of that is running on containers that they have. So Docker. Docker is a way to run containers. There's many different varieties of containerization, but Docker right now is taking the lead. They're one of the most popular, but it's not just a single thing. When you install Docker, you get a whole suite of tools that all work together. The Docker engine takes care of making sure you can actually tell a container to run. It gives you the ability to monitor. You can look in and see what the status of that container is. Has the process died in there? All that thing. It provides the network connection. So you don't have to try and connect those dots together. You can just let the Docker engine bring that in. Storage, you need a way to connect files or store files. Provide your website code into one of these containers. The engine takes care of those things, as well as handling the security. So the permissions for talking from one container to another to say what user inside of there has access to. And then the engine is pluggable, that you can write your own extensions to it to do any number of tasks as well. Docker introduced the concept of an image. So think of like a virtual machine image. It is, on disk, a stored copy of the state of your application, your service, whatever you're running. But the best thing they did was they implemented a layering system. So you can build it a Docker image, you can run it, you can save it. If you need to change it, what Docker has done is they've built a system so that when you make a change, you only have to update a small part of that. Kind of like how Git works. When you make a commit and push it, and your coworker then needs to pull that down, they don't have to pull the whole repository down, which would be like having to pull a fresh virtual machine image down. You can just pull, when you tell it to pull, it pulls just the small slice of that which layer has changed, and you're up and going. So it makes updates very fast. It makes sharing them fairly easy. So you get a lot of flexibility with that system. When you push them, Docker came out and they've built what they call the registry. So it's like GitHub. It's a place they run the public Docker registry that you can push images to, store them there, share them, get feedback, all that sort of thing. They also have a private Docker registry that you can run, and it gives you permissions and all those sorts of things. But the fun part about that is it's just another Docker container, so you can run Docker registry container inside of Docker and get all these layers built up. But it just gives you a common repository. And then they have the Docker Swarm, which is an orchestration tool for managing a bunch of containers. Docker Swarm is not the only orchestration tool out there. Kubernetes that Google has built, OpenShift, which is a layer on top of Kubernetes, that's from Red Hat, and then Rancher as another alternative to that. And there's more out there. We need an orchestration tool because containers don't stick around. When we're building one of those images, it's just a state at that time of how your application looks. So we can put it out, it can run, server has a hiccup, it's going to stop. But we use an orchestration system to make sure that it restarts properly and that it's back into the ecosystem. With these systems, you can do a lot more, though. You don't just have a server where you're telling the Docker container to run. You have a whole cluster. So you can do load balancing. They bring in routing systems. They do health checks on the containers as part of the startup process. So when you deploy an update to your container, to your image, it pushes it out into the orchestration system. The orchestration system starts to start up that container now, and it checks the health of it. It waits until enough of them are running, and they're all reporting healthy, and then it'll move the traffic over to there. If one of your containers fails or stops running during that process, it'll stop that deploy and keep the traffic routed to the old ones, so you can have seamless updates of your application without needing to stop a whole bunch of things and then replace parts of your system. And there's all, you can also, the load-based scaling and things like that are also available in these systems, that they can start and stop containers as needed. One of the other big things is that these help a lot with the problem of storage. Docker containers are not there all the time, so if you save a file into it and the container stops, your file goes away. These orchestration systems will help connect your containers to things like NFS, what's the other one? Gluster, yeah. I stopped using it so long ago. And help make sure that on that network, in that cluster of servers that are running all of your containers, the files are stored safely behind the scenes, so that when you do start new containers, your files are there as expected. Why should a developer care about containers or Docker or any of this? Those Docker images are built off of a file that you can control. It's not a complex language. It's not like learning a configuration management system like Puppet or Chef. You can put commands into Docker files and build an image to serve a task for you. So that could run a simple script. You could pull off of that, the public Docker registry, the Docker hub, you could pull an image down, use their Docker file, make a few modifications. Say, I've got one I'm working on right now that's a Ruby project. So using a public Ruby image, but I wrote my own little Docker file to add a couple of gems to it, so that when I start that container locally to work on my project, I already have an image with all of those things built into it. Then when I'm done, I'm running that on my laptop, I can take that same image, that Docker file, and build it out on the production server, and I know that it's going to be exactly the same as what was running on my machine. So it really brings back that, gets rid of the, well, it worked on my machine, why isn't it working on production? Because the image is the same no matter where we deploy it. we get rid of those problems. If you need to do more than just a single thing locally, Docker provides a lot of help for that. So you can run via different Docker containers a lot of things. You need Drupal, sure, it needs a database, PHP to execute, but what if we're using Elasticsearch or Solr? You can start a container for that, let Drupal connect to it, and be able to test that out locally without needing to find a service that will let you connect from your workstation to a remote endpoint. You can run things like Varnish, Mongo, the services that your production site might have with a hosting provider, you can run those locally using Docker in their own containers. And we're seeing this lots and lots and lots. Amaze.io, we run our local development environment. It is based on Docker. Platform, you can grab the Docker images that they're using. You have that flexibility to grab these things and run them locally, so you can test fully everywhere. And there's really no limit to that. Looking into the future, Docker had its four-year birthday recently, which is young for a software project, but it's growing fast. So now we're seeing things. Rancher, one of the orchestration services, has built an operating system for running Docker that is built on Docker. So a full operating system that everything it needs is run as a container. Microsoft has done a lot of work. They'll now let you run Windows inside of a container. But bigger than that, you can run your Linux containers on Windows. So now you're developing on Windows, but you're pushing services to a Linux server or building for a Linux system. You can run all of that locally. You don't have to set up a whole VM. We go back to that lightweight and fast thing. You can start them up as you need without introducing a lot of extra load to your system, all on top of Windows. One of the big things that's also come out recently is called the Open Container Initiative. Docker is very prevalent, but it's a closed system. The magic of what makes a Docker image is part of their secret sauce. There's a lot of movement right now to make that an open source thing, to have a standard for what images will look like in the future. And so we'll probably not be calling it Docker in the future, but some other name.
Open Docker.
Yeah, Open Docker, yeah. So, questions? I'm kind of fast. Yes?
Okay, so if you were running a Drupal container and Elasticsearch plus maybe a Varnish container, would that be considered orchestration?
No.
Okay.
No, just running them is just run. Orchestration would come into play when you're pushing it to a production system that's making sure that each one of those is up and available and ready. If one dies, that system will replace it. Or when you push an update, it will roll out that update. But running them locally as part of that, or just single containers, would not be orchestration. No.
Okay.
Yeah. So fault tolerance and load.
Yeah, failovers and all that. Yeah. Yeah.
Okay.
Mm-hmm.
How would you? So if you set up that, how would you share those images? Would it be 3 images, or would it be 1?
So that's kind of up to you. The proper way to do Docker is to build very small, lightweight images that do a single task. You can build them out to do more than just one thing, but they become harder to move around. So it depends on how you want to build those pieces. Personally, with our company, because we want what we do in Docker to be exactly representative of production, it's all in one. As we bring more Docker hosting out for the Drupal side of our business, we will, as we split production out, we'll split the local one out too. So it can change too. There's flexibility with all these services.
So in the traditional VM kind of environment, when you're tuning, you don't have to worry about other things being a bottleneck in there, right? So in Docker, when you're sharing so much of the infrastructure underneath, how do you say, you know, I got to worry about this Docker container over here over consuming resources and affecting this?
Mostly will come down to the orchestration system. There's an idea, they call it millicores, that you can set like how much CPU resource a container will get, or how much RAM that container will get, and then you use the monitoring that's in that tool to make sure that, you know, if something's trying to overuse memory, it's probably going to get an error, so you get that feedback. But there's systems for making sure they're not overusing resources.
I mean, because, you know, like some technologies try to just use whatever's available.
Yeah,
right?
totally.
I mean, if there's 64 gig of memory on this thing, I'm going to try to use it all.
Yeah.
And so you would put that in the VM before, and you would just provision the VM to what you want your max to be and just let it do its thing.
Right.
IIS is like that a little bit, and SQL Server can be like that. But, you know, with Docker, is there, so you could still set memory limits?
Yeah, you can still limit the things just, you know, yeah, in a similar fashion. Not the same way, but similar, yeah,
Right.
definitely.
How do you find like configuration or images or something like that for something like, I know Elasticsearch runs on a different kind of DB. How would you find an image for?
So the Docker Hub is the biggest repository of public Docker images, but you can also explore just searching for Docker files that you would then build an image off of locally. But most of the projects are backed with a public Git repo that you see on Docker Hub, so you can see what's in there. On the Docker Hub, when you're looking at an image, there'll be a link to the Docker file, so you can see what's built in there already, and then decide if that will fit your needs, or if you can take it and extend it by writing another Docker file that builds from their point, or file an issue on their Git repo. You know, the public ones are very open, and the very popular ones have very active development, and a lot of, you know, you can get a lot of things done to help you out as well. So,
are there any that you find particularly useful for doing mobile dev, like as the basis for doing development, or like tool sets, or anything?
well, I'm biased there because we have our own local environment. So on Docker Hub, the Amazy.io organization, we have images that represent the different configurations we run. But I've also used those. What's that?
Including your local development?
I use it exclusively. So I've even taken my own personal Drupal projects, and even though they're not on our company's systems, they're on other stuff, I can use that same environment for all of my projects. I haven't started Apache on my Mac in 6 months, just because of that, because I've been able to take and you know, it's a few small changes to settings files, things like that, but that will depend on what image you're using, how it interacts. I went to the Docsol session yesterday, and his feedback was don't actually use the Drupal image that's on Docker Hub. It's a demo project to show off what can be done. It's not good for development. Docsol is a tool you might look into as well.
SAL or?
DOCKSAL.io. Oh, well, yeah, Docsol, and it's not exclusively Drupal, but it is very Drupal centric.
So you mentioned running the Docker stuff within a VM. Do you typically do that? What do you see as the advantages, disadvantages? Or?
Well, it depends on how you. So for local development on the Mac, right now I do run in a VM because there's some performance issues with Docker for Mac. It's better to run it in a VM right now. They're working on that actively, but on Linux, native Docker. It's great, it's fast. On our production systems, those are VMs because the cloud provider is giving us a virtual machine. But then we're running native Docker on those systems to provide those services.
Something I've run into running development environments in a VM on a personal laptop or on a laptop is just that, like, if you have a really large database, the VM tends to bog down. Does Docker make any difference as far as that goes, or just make it slightly?
That's really dependent on the resources that you've provided the VM and what's available on your laptop. You can make it a little bit easier to deal with by making sure you're not moving cache tables around and things like that, but that's our laptops, our workstations generally have limited hardware, so that's just kind of a thing. Anyone else? Cool.
Is there
Oh,
any way, sorry.
Yeah.
Sorry, go ahead.
go ahead.
Is there any way to programmatically change or something like that? Like, say you're running 2 Docker containers and they're sites that talk to each other, and they each have a URL. The production URLs are obviously going to be different than the local ones. Is there any way to programmatically change that or make them just
Connecting to them is dependent on a lot of things. So, like in a production system, those orchestration systems provide that routing. They'll actually run a container that acts as a router. So you don't talk straight to where the container is running. You talk to a system in front of it, and then it knows where to send your request based on the URL. Locally, it depends on what tools you use. So a system like Docksol or our local environment, it has a similar configuration where it's providing some DNS to help you match the name to the local environment, and then a routing layer, HA proxy or something like that then knows what site you asked for and where that container lives, and then it connects the dots. If you're not using a system like that, then you have to dig into Docker a little bit, and there's a way to find out what port it's running on, because it's not like a VM where it just talks by name. If Docker's running on my laptop, it's using a local port to listen to. So it's not running like normal web is port 80. The Docker image won't be running on that locally. My laptop won't let it do that. And so you have to do some. So using a tool around Docker is a very good idea.
Which
Yeah.
one did you recommend?
Docksol is a good one. It's getting a lot of work. Ours is, we really like our own tool. We have 2. The one for Mac is called Cachalot, Cachalot, and that's a homebrew tap that installs for you.
I'm used to that. I like Tesla.
Yeah. And there's others out there too. I can't remember the other names. I've looked at a few, but none of them really met a need any more than mine were already taken care of. So, yeah.
So to kind of get going, besides Docker itself, on a local machine, what else do you need to install, or what else would you install to kind of, you've talked a lot about Kubernetes and other Docker orchestration tools, but what do you need to actually get started on the laptop?
Locally, you need Docker. A lot of stuff will use a system called Docker Compose. It's a configuration file that then helps you run things in Docker. But then I would look for the helpers like Docksol to take care of the extra, because there's a lot of extra nuts and bolts that are involved there. Look at a tool like that but that's basically it. Is you need, and their tool will actually install everything for you. Ours is in our docs as to the setup type steps that are involved. Yeah. Cool. Well, thank you.
Thank you.